With this problem, I am to find the inverse of this logarithmic function and make it as simple as I can. So if I find the inverse, it means that I'm going to switch my x's and y's. So I'm going to start out by doing that. X is equal to log base 1/2 2x plus 3. Now, one thing you need to be really careful about in this problem is the argument of my logarithm is nicely put here in parentheses. The 3 is not part of the argument of my logarithm. The 3 is separate. It's kind of like a k, really, is what it is. So before I can do anything with this, I need to make sure that I switch my x's and y's like that. Is I need to move my 3. So I'm going to subtract 3 from both sides, and I have x minus 3 is equal to log base 1/2 of 2y. Well, my 2y, my y, which is a variable I'm solving for here to find the inverse, is trapped within this logarithmic function, and I need to free it. And the way I free something from a logarithmic function is I exponentiate it. So I'm going to exponentiate it by taking this 1/2, which I know is the base, and moving it over here. So I'm going to have 1/2 to the x minus 3 power, because remember, x minus 3 is the exponent on base 1/2 that gives us the answer 2y. So I have 1/2 to the x minus 3 is equal to 2y. So if I want to, again, totally free up my y, which I do, I need to solve for y, I can divide both sides by 2. And that's going to free up my y. But because I see that I have a 1/2 over here, I'm just going to change it a little bit. Because I think this will make it easier. It's something that you'll learn by practice. Instead of dividing by 2, I'm going to do essentially the same thing, and I'm going to multiply by 1/2. So now on my right side over here, I have just a y. And on the left side, I have 1/2 to the x minus 3 times 1/2. And this is 1/2 to the first power. Well, what happens when I have a to the third times a to the second? I get a to the 3 plus 2. I get a to the 5th. Same logic with this over here. I have 1/3 to the x minus 3, and I have, 1/2 to the x minus 3, and I have 1/2 to the first. So this is going to be the same thing as 1/2 to the x minus 3 plus 1 is equal to y. So I have y is equal to 1/2 to the x minus 2. And to finish off making it an inverse, I go f minus 1 of x is equal to y to the 1/2. Sorry, going too fast in my head. F minus 1 of x is equal to 1/2 the x minus 2. Now, a common mistake happens right at this step right here. Remember, a to the second times a to the third, because I have the same base, is equal to a to the 2 plus 3 equals a to the 5th. It does not equal a squared to the 2 plus 3. I have the same base. So what a lot of people do with this kind of a problem is they say, oh, well, I have 1/2 times 1/2. So really what I have is 1/4 to the x minus 3 plus 1. This is not true. Don't make that mistake. Same base, all I need to do is add the exponents.